Hey guys, welcome to question MM198 of the Maths Methods Fortify study guide. So, in this question we have well, first of all, we're not allowed to use our calculator, so please remember that. But we've got this rectangle ABCD. The vertices A and B lie on the x-axis, and the vertices C and D lie on the graph of y equals 4, take 2x squared. The point at C is CD, where C and D are positive real numbers. Awesome. And it shows us that D is at negative C and D. Awesome. Our first task in part A is to find the area A, so A is equal to our area, of the rectangle ABCD in terms of C. So that's our biggest thing here, guys. Fantastic. So guys, first things first, if you're ever struggling with a question like this, just break it down into the components. So we're looking for the area, and the area of a rectangle is simply length times width. So let's start with that. So, oops, I don't know where I got 4 from. Area equals length times width. Awesome. So let's deal with this. So the length of our rectangle, I'm just going to say that the bottom is the length because to me that looks longer and I like using the longer as the length, which is this part here, right? We know that the coordinate C is at C, right? Our x value at this point is C, which means that from 0 to this point here, that's C, units in distance, right? If this is C, and that's negative C there, that means that this distance is also C. So what's the total distance of this whole thing? 2C, right? So our length, immediately, we can say is 2C. Fantastic. Now we need our width, right? Which is actually the height of the rectangle in this case. So our y value at this point is D. So we're just going to say straight away that our width is D. Cool. So we know that our area is given by 2C times D, but we don't want a D in here. We want C, right? We want everything in terms of C. So how can we find D in terms of C? Well, we know that this graph here follows the equation 4 take 2x squared. We know that the x value at this point is C, which means that we can create a y value with C in it, right? So we know that C is also at C, but the y value is given by this, 4 take 2x squared, where our x value is C. So 4 take 2c squared, right? This is the same thing, which means that our D here is equal to 4 take 2c squared. Fantastic. So we've pretty much got everything in terms of C here, but I'm just going to simplify it a little bit further. So this is the same as, well, 4 and 2 have a common factor of 2, which means I'm going to take 2 out the front here, which means I get 2 take C squared. 2C times 2 is 4C, so 4C, 2 take C squared. This is our final answer for part A, guys. That's your first mark, first and only mark. That's it. If you have any struggles with these kind of questions, just break it down. So like your area is equal to length times width. What's my length? 2C. What's my width? D. How do I get D in terms of C? Get the y value from the equation. So that's part A. Let's move on to part B. And as always, guys, I'm sure you're super sick of hearing me say this by now, but I shouldn't have gotten rid of that. X CD, awesome. I'm sure you're super sick of hearing me say this, but if you do have any questions, put them in the comments, I'll answer them. So we know that the area, I'm just going to rewrite this down here, the area was equal to 4C, 2 take C squared. Sweet. And part B, which is 3 marks this time, asks us to find the maximum value of A and the value of C for which this occurs. So max A, and then C as well, right? So our C value here. Yeah. Fantastic. So we know that A is equal to 4C times 2 take C squared. And we know that a maximum area occurs when the rate of change of that area is 0, right? So at our stationary point. So we know that the area is given by this, which means that our maximum area is going to be at the point where this graph has a turning point, okay? So that means that we need to find dA dC, okay? Which is the derivative of this area function. So I'm just going to, before we do that, I'm just going to expand this out to make it easier. So 4c times 2 is 8c, and then minus 4c cubed. So we need to derive or differentiate 8c take 4c cubed. 8c derived is just 8, minus 3 times 4 is 12, c squared. Awesome. So from here, guys, we know that the maximum occurs when a stationary point happens, which means that dA dc is equal to 0. So we get 8 take 12c squared. We can divide both sides by 4, which gives us 2 take 3c squared. Rearranging this, we get 2 equals 3c squared. 2 over 3 equals c squared, and then c is equal to square root of 2 over 3. Awesome. So, guys, we can say that because c is a positive real number, as it mentions in the question, yes, it does mention that in the question, so we know that c is positive. So this should, actually, I shouldn't have written that straight away. I should have written c is equal to plus minus root 2 over 3, but c is greater than 0 because it's positive, so c equals root 2 over 3. Awesome. So that is our second mark. So our first mark actually comes when we recognize that we have to derive this and make it equal 0. So somewhere in between here, you'll get your first mark. Your second mark comes when you recognize that c is equal to root 2 over 3, and including this root 2 over 3 in everything you do, right? So, sorry, when I say that, I mean the whole 2 over 3 has to be under the square root. Sweet, so now that we know our c value, we need to find our area, right? Because we haven't actually found our maximum area yet. We've just found the value of c for which the maximum area occurs. So, again, we know that a is equal to 4c outside of 2 take c squared. We know that c is equal to the square root of 2 over 3. That's 2 take root 2 over 3 squared. Yep, cool. From here, we get 4 root 2 over root 3. So I've just broken the root 2 over 3 up into root 2 over root 3. And then inside, we get 2 take away the square root of 2 over 3, all squared. The square root and the square just cancel, so we get 2 over 3 here. From here, we get, I'm just going to rewrite this bit. Yep, 4 root 2 over root 3, outside of 4 on 3. If you're not too sure how to do this, guys, you really need to review that because you'll need to know that for the exam pretty consistently. So, from here, I'm just going to expand all this out. So we get 16 root 2 over 3 root 3. Now, we don't like having square roots on the bottom, so I'm actually going to rationalize this denominator, which means I'm going to times it by root 3 over root 3. So I'm multiplying, effectively what I'm doing when I do this is I'm multiplying it by 1, because it's root 3 over root 3, that's just 1, but I'm getting rid of the square root on the bottom. So what that does is, we then get 16 root 2 times root 3. Root 3 times root 3 is just 3, and then 3 times 3 is 9, so we get 9 here. This gives us 16 root, and with these roots multiplying, we just multiply what is in the root, so we get 2 times 3, which is 6, so we get 16 root 6 over 9. That's our area, units squared. That's it. So that's your third mark there, guys. So I would actually, if I was in an exam, I would actually rewrite maximum area of 16 root 6 on 9 units squared occurs when c equals root 2 over 3. And that would be my final answer inside a red box. So guys, if you have any questions, hit me up in the comments below. But otherwise, thanks for watching, and yeah, let me know if you have any questions.